Express 8 by 3 in the decimal form by long division. Solution. By dividing 8 with 3, we get as follows. Therefore, 8 by 3 is equal to 2.6 bar, which is a non-terminating recurring decimal. Express 17 by 8 in the decimal form by long division. Solution. By dividing 17 with 8, we get as follows. Therefore, 17 by 8 is equal to 2.125, which is a terminating decimal. Express 0.84 bar as a rational number, P by Q form. Solution. Let x is equal to 0.84 bar, which is represented as equation 1. Multiplying equation 1 with 100 on both sides, we get as equation 2. Subtracting 1 from 2, we obtain as follows. Therefore, P by Q form of 0.84 bar is 28 by 33. Let us have a look on irrational numbers. Let us consider the equation x square equal to 9. Solving this equation, we obtain x values as -3 and +3. Now, we know the representation of the numbers -3 and +3 on a number line, which is as shown. Similarly, let us take the equation 2x equal to 5. Here we obtain x value as +5 by 2, and the representation of it is as shown. Finally, let us consider the equation x square equal to 3. Taking square root on both sides, we get as shown on screen. Thus, x value is obtained as √3. Such type of numbers can't represent on a number line directly. For this, we need to know the value of √3. So, let us find √3 value by long division method. Let us solve an example of irrational numbers. Find the value of √3 by long division method. Step 1. Place decimal point after 3. Step 2. After decimal point, write zeros and pair them putting bar over them. Step 3. Find the largest square smaller than 3, that is 1. Subtract 1 from 3, which leaves 2, and write 1 as the first digit of the quotient. Step 4. Take the remainder 2 and bring the first pair of zeros to down, and then add a decimal point to the answer. Then follow the same steps to find the next digits. Step 5. Now take the first digit of quotient 1, but make it double, that is 2, and make that number 10 times. Then take a number of your wish, say 7, and it must be less than 200. As in the example, product of 27 and 7 is 189, which is less than 200. Step 6. Subtract 189 from 200, which leaves 11, and bring the pair of zeros to down. So, here the value of root 3 is 1.732 and so on. Let us know in detail about irrational numbers. The irrational numbers, like root 3, by solving we obtain the value as non-terminating and non-recurring decimal. Thus, we conclude that the decimal number is either terminating or non-terminating recurring decimal, which can be expressed in the form of p by q, is known as rational number. As here, the number root 3 is non-terminating and non-recurring decimal. So, here we can't express root 3 in terms of bar, hence it is known as irrational number. And such type of numbers cannot represent in terms of p by q. In short, the non-terminating, non-recurring decimals are also known as irrational numbers and are denoted by S or Q dash. The above table describes some root values. From the table, we observe that if n is a natural number other than a perfect square, then root n is an irrational number. Thus, we identify root 1 and root 4 are rational numbers, and root 2, root 3, root 5 are irrational numbers. About pi. Pi is defined as the ratio of the circumference c of a circle to its diameter d, that is pi equal to c by d. As pi is in the form of ratio, there is no common unit to measure the circumference c and diameter d of the circle. Either c or d should be irrational if we want to measure accurately. So pi is regarded as irrational. The Greek genius Archimedes first computed the value of pi, and he showed the value of pi lies between 3.140845 and 3.142857. The great Indian mathematician and astronomer Aryabhatta, 476 to 550 AD, found the value of pi correctly to 4 decimal places, that is 3.1416. Pi equal to. The decimal expansion of pi is non-terminating and non-recurring. So pi is an irrational number. An approximate value of pi is 22 by 7. Albert Einstein was born on March 14, 1879, and the same day it is celebrated as Pi Day.